Hello, this is Math 140, day 11. I've got odds and ends, a mixed bag of items taken from Alex about quadratic equations. And they're small things, each by itself, so I'll just put that into one video clip. First thing, the discriminant. If you have a quadratic equation in standard form, then I discussed that in my first video. The discriminant here is b squared minus 4 times ac. It is what goes under the square root in the quadratic formula. Give it a name, call it capital D. And if that is greater than 0, then we get two different real solutions. If D is equal to 0, then we just get one real solution. And if D is less than 0, then we get no real solution. But we do have two complex solutions. Like in my previous example from the last video clip. So how could this happen to you in an exam problem? In x squared plus 10x plus c equal to 0, what values of c gives you two real solutions, one real solution, no real solution? This can happen if you are not solving an equation, but designing an equation, and you want this to have two solutions or one or zero solutions. You could be in that position of authority at some point. So how do we need to pick our C? You look at your discriminant, the capital D, which is b squared, that's 10 squared, minus 4 times 1 times c, so 100 minus 4c. And when is that positive? It's positive if c is less than 25. It's equal to 0 and c is equal to 25, right? You solve 0 is 100 minus 4c, solve it for c, get that 25. And I actually did that part first. This is a useful trick. Always do the equation first, even if it's not listed first. And then you think about what happens if my C is a little less. That means D becomes bigger, so it becomes positive, and it solves the first part for you. When you make C smaller, D becomes bigger, and we solve the first part. And the last part, and it's quite obvious, less than 0 when C is bigger than 25. And those are also the answers for parts A, B, and C, obviously, right? So that's how you can use that discriminant without actually solving an equation to tell how many solutions it has. That's sometimes useful. That's the first item in my mixed bag. Second item, a word problem. So I stole this from Alex. A swimming pool has a length which is 7 feet less than 3 times the width. And the area is 66 square feet. What's the length and the width? Or what are the dimensions? Okay. First step is give one-letter names to relevant quantities, which are obviously length and width. Lowercase l is frowned upon because it looks like a 1. Don't do that. Capital L is fine. Next step, we translate the clues into equations. One thing is length is 7 feet less than 3 times the width. Say 3 times the width, subtract 7. You get that length is 7 feet less. And the area, so 66 square feet, is length times width. And it doesn't even say that the swimming pool is supposed to be a rectangle. So by default, it is a rectangle. Now we've got 2 unknowns, 2 equations, and this one is one where we best substitute the 3w minus 7 for the L. So we get 66 is 3w minus 7 times w. It's a quadratic equation. We can solve that. So we just need to bring it into standard form. Expand this out. We got 3w squared minus 7w. Subtract 66 from both sides. You got 0. Now it's in standard form. Now we're talking. And I don't see obvious answers, so I'll just apply my quadratic formula. W is the opposite of the linear coefficient. That's the b, so it's a 7. Plus minus square root of 7 squared is 49. Minus 3 times 4 times 3 times negative 66. Double negative is a plus. The whole thing divided by 2 times 3. That comes out of the quadratic formula. Now you want to simplify this a bit. Most of you will whip out a calculator, but it's feasible with paper and pencil, and you end up with 441 because I've worked it out. Divided by 6. Then the square root of 441 is a real number, of course. So we have two different real solutions. And that square root is actually a nice integer, is 21. So if you use the plus sign, we get 28 divided by 6, which is 14 divided by 3. Or it's 7 minus 21, that's negative 14 divided by 6. So negative 7 divided by 3. Okay. Two possible answers for the width of my swimming pool, but of course, a negative number does not make sense. You mention it, but just discard the negative 7/3. My W has to be 14 over 3. And the length, also asked about the length, is 3W minus 7. So what is that? 14 minus 7 is 7. And that way, you can arrive at problems where you need to solve a quadratic equation, and then you better need your quadratic formula. And sometimes you get nice rational answers or even integers. And sometimes you get weird square roots and need a calculator. But the quadratic formula will always tell you what's going on. All right, that's the mixed bag for quadratic equations. More about this in lecture.